Scientists began a series of studies on NASH, which is the advanced middle stage of non-alcoholic fatty liver disease, and on vitamin E in 2004. And based on their knowledge that NASH arises from persistent insulin resistance and oxidative stress, they examined the effects of Actos, which is an insulin sensitizing drug, and vitamin E. The patients receiving both the vitamin E and the Actos had improvements in more parameters than the patients did on the vitamin E alone. In a follow-up study, the subjects received either vitamin E at 800 international units per day, or the Actos at 30 milligrams per day, or placebo, for 96 weeks. Both treatments improved the levels of liver cell injury markers in the blood, and both reduced the liver fat levels and inflammation, but only the vitamin E produced significant improvements in the appearance of liver tissue on the biopsies. Vitamin E is a powerful antioxidant, and it's an obvious choice once the role of oxidative stress was made clear in non-alcoholic fatty liver disease. People with fatty liver disease and NASH have depressed levels of vitamin E in their blood, and this results in the increased oxidation. Even relatively low doses of vitamin E, at 450 international units per day, can reduce the circulating liver enzymes, which are a chemical marker of liver cell injury. Important animal studies refine our understanding of how the vitamin E works. One study provided the first evidence that the vitamin E prevented the non-alcoholic fatty liver disease before it develops, largely by reducing the oxidative stress, inflammation, and liver cell death by apoptosis. Another study demonstrated a vitamin E-related reduction in the oxidative damage and tissue levels of the inflammatory mediator tumor necrosis factor alpha, while beneficially reducing the PPAR gamma activity. This wealth of animal and now human data clearly supports the daily use of 800 to 1200 international units of vitamin E for the prevention and the treatment of non-alcoholic fatty liver disease and NASH. Just as vitamin E fights the oxidative and inflammatory components of non-alcoholic fatty liver disease, the omega-3 fatty acids attack the problem of lipotoxicity, while contributing considerably to the anti-inflammatory activity. People and experimental animals with insufficient omega-3 in their diet are prone to non-alcoholic fatty liver disease and type 2 diabetes. Increasing the amount of unsaturated fats like omega-3s in the cell membrane is associated with improved insulin sensitivity, and supplementation with omega-3 rich fish oil results in the activation of the important metabolic sensor called the PPAR alpha in the liver cells, suppressing the production of new fat molecules. Omega-3s also contribute to improved insulin sensitivity, a reduction in serum triglycerides, and the stimulation of fat utilization in liver tissues and skeletal muscle. A long-term human trial using 1,000 milligrams per day of omega-3 revealed significant decreases in serum markers of liver cell damage, triglyceride levels, and fasting glucose. Most impressively, supplemented patients displayed improvements of their liver's appearance and the blood flow on ultrasound exams, providing graphic evidence of the supplement's benefit. Another study found supplementation with 750 milligrams of EPA and 527 milligrams of DHA 3 times per day for 24 weeks decreased the triglyceride levels in individuals with non-alcoholic fatty liver disease. Olive oil also decreased the accumulation of the triglycerides in the liver, but the fish oil provided better antioxidant activity. At the same time, it improves insulin resistance by decreasing liver inflammation, and the long-term consumption of olive oil that's enriched with omega-3 fats in patients with non-alcoholic fatty liver disease is able to improve the liver texture on ultrasound exams, while improving the serum markers of liver injury and increasing the protective adipositin levels. Clearly, the omega-3 fatty acids have earned their designation as an innovative therapy for non-alcoholic fatty liver disease. The constant exposure to oxidative and toxic stress makes the liver cells especially vulnerable to the depletion of glutathione, which is a natural antioxidant that participates in many liver detoxification reactions. The nutrient S-Adenylyl methionine can replenish the glutathione levels, and it can restore the liver cell protection to normal. In individuals with alcoholic or non-alcoholic liver disease, supplementation with 1200 milligrams of SAMe daily increases the liver's glutathione levels. Studies using agents that increase the SAMe levels are known to reduce the severity of the non-alcoholic fatty liver disease. SAMe and other liver antioxidants improve the levels of liver enzymes, which are an early marker of cellular damage. The SAMe supplements improve the microscopic features of the non-alcoholic fatty liver disease, which are associated with fatty degeneration, inflammation, and tissue death. And the SAMe also downregulated the damaging pro-inflammatory genes in an animal model of non-alcoholic fatty liver disease. A major discovery about the SAMe is it directly stops the progression of the relatively mild non-alcoholic fatty liver disease to dangerous NASH. The NASH develops as a result of second hits, that is, the additional events that damage the liver cells after the non-alcoholic fatty liver disease has already developed. One of those hits is the steady depletion of the SAMe, and this has led to the interest in using the SAMe to prevent the NASH from developing in people who already have the non-alcoholic fatty liver disease. Another molecule that supports and replenishes the natural antioxidant glutathione is N-Acetyl cysteine, a versatile sulfur-rich compound that prevents liver damage following an acetaminophen poisoning. It rapidly restores the depleted glutathione levels, sparing the liver cells from the effects of oxidative damage. An N-Acetyl cysteine derivative called S-NAC was recently shown to prevent the onset of non-alcoholic fatty liver disease in rats who were fed a liver disease-inducing diet. In humans, the combination of N-Acetyl cysteine at 1200 milligrams per day with metformin at 850 to 1000 milligrams per day improved liver appearance, and it reduced fibrosis in patients with non-alcoholic fatty liver disease. And given to rats with non-alcoholic fatty liver disease, the N-Acetyl cysteine stimulates the regeneration of healthy liver cells in animals that have part of their livers removed. Extracts of milk thistle have long been used for liver protection. The silmarin is composed of 6 major active molecules such as silibin, and these are known as flavonolignans, and these have exceptional antioxidant and anti-inflammatory activity. One very effective combination is silmarin plus vitamin E and phospholipids such as phosphatidylcholine. This approach improves the overall antioxidant activity of the compound. In animal studies, the combination limited the liver depletion of the natural antioxidant glutathione, and it reduced mitochondrial stress damage. Human trials have shown that a preparation providing 376 milligrams of silibin, 776 milligrams of phosphatidylcholine, and 360 milligrams of vitamin E produces a therapeutic effect in patients with a variety of different forms of liver damage, improving the insulin resistance, reducing the liver fat accumulation, and reducing the blood levels of the markers of liver scarring. Phospholipids are fat molecules with phosphate groups attached. They're major constituents of cell membranes in animals, and one of the most important phospholipids in humans is phosphatidylcholine. Higher amounts of phosphatidylcholine in the cell membrane help to assure the membrane integrity in the face of oxidative and other stresses, and they also help to limit the progression of the non-alcoholic fatty liver disease into NASH. A particularly rich source of phosphatidylcholine molecule is a mixture called polyenyl phosphatidylcholine, or PPC, and it's derived from soybeans. The PPC supplements in animals attenuate non-alcoholic liver fibrosis and even accelerate its regression. The PPC appears to exert this effect in part by blocking the oxidative damage to the cell membranes. A separate mechanism is the reduction in the high cholesterol levels that precede the non-alcoholic fatty liver disease formation. And the PPC also prevents the proliferation of scar tissue in the non-alcoholic fatty liver disease and other forms of liver toxicity. And the PPC restores the liver cell levels of SAMe, which provides additional liver protection. Resveratrol protects the liver tissue against the ravages of alcoholic fatty liver disease through its antioxidant effect, buffering the impact of alcohol. It also activates two critical signaling molecules, SIRT1 and AMPK, which are inhibited by alcohol, and are also dysfunctional in metabolic syndrome. These effects make it highly promising for the prevention of non-alcoholic fatty liver disease, the liver manifestation of metabolic syndrome. In animal studies, resveratrol activates AMPK, which in turn reduces liver fat accumulation, suppresses new liver fat formation, and reduces insulin resistance. Research suggests the gastrointestinal and immune system jointly impact various liver diseases, including non-alcoholic fatty liver disease. While the exact relationship between the gut microbiome and the liver is unknown, a dysfunctional gut barrier might increase the bacterial flow to the liver, contributing to the development and the progression of liver disease. One mechanism behind this damage is the activation of an immune response causing hepatic injury. The intestinal microflora defends the body against pathogens, and it maintains immune function and intestinal wall integrity. Probiotics contain isolated and purified live microorganism strains. Prebiotics are non-digestible food ingredients, and these support the growth and the metabolic activity of the intestinal bacteria. Both have a similar objective: to support the intestinal microflora. In early controlled clinical trials, probiotics were found to significantly reduce liver enzymes, TNF-alpha, and total cholesterol, while improving insulin sensitivity. More recent trials have built on these findings. In a randomized, double-blind, placebo-controlled trial, 52 people with non-alcoholic fatty liver disease took either a synbiotic, which was a synergistic prebiotic-probiotic blend, or a placebo twice a day for 28 weeks. Both groups followed dietary and physical activity recommendations. The treatment group demonstrated improved inflammatory and liver function markers compared to the controls. In another randomized control trial, 64 obese children with sonographically confirmed non-alcoholic fatty liver disease received either a probiotic capsule or placebo for 12 weeks. At the end of the trial, over half of the probiotic group had normal liver sonography, compared with just 16% in the placebo group. On average, the probiotic group also had significantly improved liver enzymes, as well as reduced cholesterol and triglyceride levels, and a smaller waist circumference. In a randomized, double-blind, placebo-controlled trial, 50 lean people with non-alcoholic fatty liver disease received either a synbiotic or placebo for 28 weeks. Both groups followed a healthy lifestyle plan. Compared with the placebo, the treatment group experienced a significantly greater reduction in liver fat and fibrosis, as well as fasting blood sugar, triglycerides, and 2 inflammatory markers. Non-alcoholic fatty liver disease and NASH are progressive conditions, and they require the patient's collaboration with a qualified physician. Because the liver metabolizes many nutrients and drugs, it's important that liver patients not add substances to their regime without the cooperation and close monitoring by a qualified physician. The goals of the therapy are to reduce the accumulation of fat in the liver tissue by decreasing new fat synthesis and increasing the utilization of the existing fat stores in the liver, to minimize the free radical production and to enhance the free radical scavenging in the liver tissue, and to reduce or eliminate the inflammatory response of the fat-infiltrated liver tissue to prevent the progression of the non-alcoholic fatty liver disease to the more deadly NASH, which is the precursor of liver failure. For more on herbs, supplements, and natural treatment plans, check out my website.